Hello everyone, in this video I'm going to be writing this logarithmic expression in expanded form. So let's just go ahead and jump right into it. So I have the natural log of 2x plus 3 over x squared minus 3x plus 2 all squared. So what I want to first do is use the power property of logarithms. That's the first thing I notice is this 2 right here. And so what I know is I can write powers in front of the logarithm. So it becomes the product of the power and the logarithm. So then I get this. Then what I notice is I have the natural log of a quotient. And so I can use the quotient property of logarithms. And so I'm going to have 2 times the natural log. So when I have the log of a quotient, that's equal to the log of the numerator minus the log of the denominator. This minus this. Okay. So then I see that I have this x squared minus 3x plus 2, and I'm going to go ahead and factor that. So the natural log of 2x plus 3 minus the natural log. And I'm going to go ahead and factor this as x minus 2, right? X minus 2, and then x minus 1, because x minus 2 times x minus 1, these two binomials multiplied together get me this. So I'm using trial and error, where a equals 1. So I have the natural log of x minus 2 times x minus 1, put parentheses here. So I have minus the natural log of x minus 2 times x minus 1. Okay, and of course I am multiplying 2 to everything. So I'll put these brackets there. Okay, so then what I'll do here is I have the product. I notice this, I have a product of these two factors. So when that happens, what I have is the natural log of x minus 2 plus the natural log of x minus 1. I can use the product property of logs. So I have this. Right, because when I'm taking the log of a product, that's equal to the sum of the log of each factor, right? So like back here, I had the log of a quotient. So I can use a quotient property of log. So that's equal to the difference of the log of the numerator and the log of the denominator. Of course, we're using natural log. But just in general, when you have a log of a quotient, it's a log of the numerator minus log of the denominator. When you have a log of a product, so we have these two factors, we're multiplying them. It's equal to the sum of the log of one factor and then the log of the other factor. Okay, so then what I notice here is I'm going to distribute this minus sign throughout all of this, right? Because I have these parentheses. So I have 2 times the natural log of 2x plus 3 minus, so I'm going to distribute it here, minus the natural log of x minus 2, and then minus the natural log of x minus 1. Okay. So then I'm going to distribute the 2 throughout all of this now. So I have 2 times the natural log of 2x plus 3 minus 2 times the natural log of x minus 2, minus 2 times the natural log of x minus 4. And that's it. That's this logarithmic expression written in expanded form. Okay, so again, we use the quotient property of logs. Well, we use the power property of logs here, the first step, then the quotient property of logs. So I subtracted. And then here I factored. I noticed that this can be factored into two binomials. So I need to find two numbers that multiply to get positive 2, but add to be negative 3. And here, this next step here, I use the product property of logs. So I wrote it as a sum of the logs of both factors, and then I distribute the minus sign throughout, and then I distributed the 2, I multiplied 2 to all of this. Okay, let's do one where you're writing, when you're going the other way, you're writing it in condensed form. So what I notice here is the 1/2 can be written as a power, right? And same with the 4. Minus 1. That's natural log of x squared plus 1 to the 1/2 minus the natural log of 1/2 to the 4th power minus, I'm going to keep this 1/2 here. And I notice that I have the sum of 2 logs. So that's the natural log of the product of both factors. So the natural log of x minus 4 plus the natural log of x will be the natural log of x minus 4 times x, because I have a sum. Okay, then what I'm going to do here, I'm going to go ahead and write x squared plus 1 to the 1/2 as the square root of x squared plus 1 minus the natural log. I'm going to write 1/2 to the 4th, that's 1/16, right? 2 times 2 times 2 times 2 is 16. And then here I have minus, I'm going to write the 1/2 as a power, right? Because this numbers in front of the log can be written as powers. So to the 1/2. And then now I have the natural log of a difference. So in that case, I'm going to divide this first argument by the second. So the square root of x squared plus 1 divided by 1/16. Okay, and I'll put this like this, minus the natural log. I'm going to write this, I'm going to rewrite this as a root. So 1/2 power, we know that's a square root. And I'm just going to write this as x times x minus 4. Okay, and then that equals to, well, if I'm going to divide these two, that over 1, this is the same thing as square root of x squared plus 1 times 16. And I have minus the natural log. I can multiply these out. I'll go ahead and do that. So x squared minus 4x. And then here, I'm going to rewrite it as, I'm going to multiply these two. That'd be the natural log of 16 times the square root of x squared plus 1. And I have minus the natural log of the square root of x squared minus 4x. And then so I have the natural log of 16 square root of x squared plus 1 divided by square root of x squared minus 4x, because I'm subtracting 2 logs, so I divide this first argument by the second. And so that is all I have for now. I hope this helped. I have many other videos of different topics. Please go check those out. Again, I hope this helped. and I will see you on the next video. Thanks, guys. Bye.